Hello, and welcome to a new session. Today we are going to be talking about methods of human-centered design, how we can apply these concepts in designing different systems. And we want to be able to design same useful and trustworthy systems in the age of AI. Our learning objectives for today include be able to list various techniques to implement the human-centered design principles. Also, we are going to be describing how or which are the core human-centered design principles, explain how AI can help us in the design process. We want to identify specific aspects related with AI that are going to impact in the usability and in human factors and amplify risk. And we are going to explore a three-phase human-centered design methodology that is going to help us to design and evaluate health information systems. That said, let's start with the overview. When we talk about human-centered design, then this is a structured approach that allows to design any system or any artifact, but it is basically grounded in understanding the user, their needs, what they do, how they think, and the aim is to support real tasks in real context. And ultimately, what we want to do with human-centered design is to reduce risk, reduce errors, and unintended consequences of system implementation. This, when we put that in healthcare, is going to be critical because errors can cause harm in individual, groups, or population level. And any problem with trust and usability could impact directly the outcomes. And we can create morbidity, we can create mortality, and that's harm. And also, since we have that risk, there are a lot of scrutiny and regulations around health information systems, and that we need to document how the user has been involved. That's why the user needs, in the concept, needs to be part of the team when we are designing systems. There are several approaches that has been published in the literature, and but they have commonalities. And some of the examples that we can find is approaches that they do analysis of the user in their context, or they can do identification of user requirements, or this approach could be for development of an interface or the evaluation of the interface in the lab. All these are methodologies and multi-phases human-centered design methodologies. And one really well known, especially that was born for designing electronic health records, is called TURF, TURF. And T stands for task analysis, and basically is what the people do. We need to understand what are the things that people do. Then we have the U, that is the user, and who is that individual. And we have the R, that is the representation, is with what they are doing that and how we can change that tool to make it better. And F is the functionality and is the ultimate goal that we want to optimize or perform. Then that's kind of an approach that we can put there for the system and understand the different elements. But today we are going to be centering in a simplified version that have three phases in the cycle of design. Then when we think about connected health and all the devices, we are experiencing even more challenges because those data flows, those connected devices, they have different interfaces, they have different ways of interactions, and that's creating new ways to interact with systems. And sometimes in healthcare, the user interface requirements that apply for traditional systems, they are not really transferable to healthcare. And this problem is amplified with AI, because when we have this complex systems that are working in real world environments and that are used by diverse populations, we really need to have transparency, we need to create trust, and we need to create safe environments. AI is not new, it has existed for several years. It was created in the 50s in the previous century, but it has been in the world of in the mouth of everybody because the generative AI has made a shift in the understanding of the capabilities of computer, and it has created a lot of expectations. Sometimes they are not really founded, but we need to start understanding those limitations. And that introduction of AI is introducing also additional challenges because AI multiple times, depending on what we implement, is going to have a non-deterministic output. That means that with the same data set, today I'm going to have a result and tomorrow I'm going to have a different one. And that's not good for consistency in health because how we attribute errors or not adherence or failures when we are not really consistent in the interventions. And also, it has created false trust because users overtrust the results. But remember that there has been a lot of criticism in AI because it can hallucinate, quote unquote, no? And the hallucination is just the way that the AI has been designed. And it happens when we try to use AI as generative AI for tasks that it was not designed to, but we think or we attribute some features to the artificial intelligence, the generative artificial intelligence that they are not really designed to comply, and then is when we start to having these difficulties. And of course, since sometimes we don't understand how the system works, we are going to have difficulty explaining how the system is behaving. Then nowadays we have a pressure because we need rapid development and be able to respond to the pressures of the public. And the connected health industry is moving really fast, it's highly competitive, and is operating under shorter product life cycles. Remember when we had COVID, people need to come with information systems quickly, we need to have contact tracing quickly, and we actually developed a vaccine quickly. But at the same time, all those devices and the tools that we are developing, they need to be usable, they need to be safe, and they need to comply with with the regulatory requirements. And we need to be really aware that we need to demonstrate real user value, not only novelty, because in healthcare, novelty doesn't really create that sustainable process. Then we have this tension between the speed and the safety. And of course, solution proposed for this is to have a structured, compressed approach of human-centered design that we are going to be discussing. And when we say that there is a bunch of regulations around healthcare systems and devices, the FDA requires evidence of end user involvement when we are designing things, and especially if they are going to be considered medical devices. And there are specifications when a software is a medical device, because depending on the type of recommendation or the type of output that we have in the system, then FDA is going to think that this is a medical device, and it requires similar evaluations that we do for medications or other stuff. There are also some international standards like IAC or the International Standard Organization that actually there is a definition in human-centered design requirements. And when we have AI, it does not really reduce these obligations. Instead, it's going to increase the importance of meeting them because AI can put us on risk, as we already mentioned. Then the guiding principle that we have in the ICO is that design is based on explicit understanding of the users, the task, and the environment. Is similar to that approach that I was mentioning in the third one. Users are involved through the design and the development. Then they are essential part of the team. And design is driven and defined by a user-centered evaluation. And we are going to be discussing those different elements. Also, in the guiding principles, this is an iterative process. It's not that you just talk with the user today and you forget about the user and you just come with the product and present that to the user. No, it has to be every single step and an improvement that is going to be increase in improvement and continued improvement. And the design needs to address the whole user experience since they have the intention to interact with the system all the way to the outcomes and the follow-up. And as I mentioned, this design team includes multidisciplinary skills and perspective, but part of that team is going to be the user. Then the human-centered design in the era of artificial intelligence needs some extensions. Okay, and then we need to be able to address the user trust and calibrate the systems. We need to understand the limitation of the artificial intelligence tools that we are using. We definitely need to have transparency and explainability of the algorithms and the outputs that we are having out of the systems. We need to be able to recover from artificial intelligence errors, and we need to understand that human-centered design is a process literacy, and it matters more than just going through checklists. We really need to be involved in what is the process, understand that, and it's not just checking the box. Then let's go and look into that proposed framework or methodology. It has been proposed roughly 10 years ago, and it says that it has three phases. One phase where you establish the context, second phase where you have experts involved in the evaluation, and at the end you have evaluations with the end users. And as you see, this is an iterative process because if we find failures, we can go and reiterate with the previous phase and fix things and evaluate and try again in the next phase. If it doesn't work, then we'll go back, but if everything is okay, then we move to the next one. Then let's talk about phase one. Phase one, then the goal is to gain a deep understanding of the user, the task, the environment, and the risk. Here is where we can use that turf approach. Then a task is the different steps that a user need to conduct. The user is who is the user again. The representation is the actual device that we are using, the interface that we are creating, and the functional analysis is that goal. How we can do that? We can have interviews, we can have surveys, we can have ethnographic observations. We can develop use cases, no, and have those representations. And on top of that, if we are using AI or creating AI systems, then we need to really identify when AI is as assistant or AI is driver. Okay, and we need to identify what are those critical decisions points, because who is going to be responsible for the errors, for the mistakes, for the wrong outcomes. Then and the specific considerations that I also want you to think when we are using AI in that phase one is what is the user mental model of the AI, what the user understands about the AI, and what are the expectations, how the user is going to be interacting with the AI. And then we need to document what is acceptable and what is not acceptable in the case of AI failure. And the artifacts that we can produce here are scenarios where users are going to be interacting with AI. We can create some states of error and uncertainty, and then we definitely need to create trust boundaries. But at the end of this phase one, what we are going to be producing is a document that is called the usability report. And the usability report is going to be those specifications about the tasks, the functions, the user, what we want to do. Then we need to create a prioritized user requirement. And there are techniques to do this, like one that is called Moscow. Moscow is a must-have, a should or would have, and wishes. And we can categorize functionalities and aspects of systems using that Moscow scale. Then you have multiple users, and for example, if must have, you can give it 5. If it's a should have, you can give it a 3. If it's a wish, you can give it a 1. And if not of your interest, it could be a 0 because it's nothing that I'm going to be using. And actually, you can calibrate that and create average or medians or different calculations to weight the need of different requirements across different personas or across different users of a system. And that's the way that you can prioritize requirements. Hey, what I'm going to be doing first? Why? Because time is limited, resources are limited, then you need to be able to solve the biggest problems first and not get lost in the wishes. We also need to document the risks and assumptions explicitly, and we are going to finish with prototypes that are going to reflect those user needs. That initial prototype is really important. Actually, we can validate those prototypes with different usability evaluation techniques that we are going to be exploring. Then, when you have that prototype, we can move to phase 2, where experts are going to take that prototype, those requirements, and that understanding of the user, and they want to identify usability and human factor problems. That phase is where the expert is going to try to identify what is wrong in the prototype that has been produced. And usually we want to do that early and cheap, because changing things when you already have written code are really expensive. But why we do this is because prototypes, they can look complete, but they can be hiding serious user experience flaws. And then if you bring those experts, literature has demonstrated how you reduce downstream risk. And actually you have a lot of return of investment in investing evaluations in early stages, even before writing that first line of code. For this type of evaluation that we want to identify problems, we use some techniques that we call discount usability engineering. And discount usability engineering is because we want to be simple, we want to make that cheap, and they are cost-effective methods. And those methods include the scenario evaluation. We already use a scenario-based design, but we can use a scenario evaluation. You can create a hypothetical case, you create that scenario, and then you use your prototype to walk through that scenario, and it's going to show you, hey, it's going to work, it's going to have so many steps, it's going to have some additional needs of information that we are not providing, things like that. Also, when you have that scenario, we can add to that a simplified type think aloud, where people is just going to the scenario and the prototypes, and they're saying, hey, this is my experience when I'm looking into this. And a more formal approach is called the heuristic evaluation. The heuristic evaluation, we are going to dip a little bit more into that, and it's a technique that is targeted to identify problems in the system and propose solutions. Then these methods are fast, are iterative, and they are well suited to compress design cycles. Then let's go through all the three methods, and in the scenarios, then this is kind of a type of extreme prototyping where you can use the scenario and rearrange the prototypes on the fly. And the idea is to reduce the level of functionality and number of features of a system to a minimum. Just, hey, what is the actual task that we want to have? And remove all the extraneous elements that we have there. And the scenarios need to be small and simple in nature. It's basically you need to log in into a screen. You want to put your blood sugar into the application. You are going to record your weight. And the changes can occur frequently, because if you have a prototype and you see a problem, then you just modify that and run the scenario again. And it allows quick and frequent user feedback, and it can be supervised for those experts. And these are paper mockups or simple prototypes interfaces, and we have tools like Figma or even PowerPoint or Balsamic to design those prototypes. The simplified think aloud is another simple method. You have a limited number of real end users that are going to be walking the through the prototypes, and you ask them to do some task similar to the scenario. But then what they are asked to do is to just speak out what they are thinking when they are navigating that prototype. And that's really successful in identifying usability issues. Actually, we can mix the scenario and the simplified think aloud at the same time. Then that analysis about those insights are conducted, and we can use notes, we can use videotaping, but notes and observations are good enough because we don't need to have a really huge lab to conduct that. And then the heuristic evaluation is when we have this group of experts and they evaluate the system using rule of thumbs. Those rule of thumbs are what we call heuristics. And the original one has 10 fundamental heuristics, but they have been expanded. And the heuristics that were created by Nielsen, they are called visibility. Visibility talks about that we need to be aware of what the system is doing. Then, and we need to be able to see the activities. Then, for example, when you have a long scroll and you have the main function hidden by the scroll, that's a visibility problem. Or when the system is doing an activity and you are not providing a feedback, like the circle that we say, hey, the computer is thinking, that's a visibility problem. Match is about our mental schemas. For example, if green is good and red is bad, but we are using the colors in a way that doesn't match our mental schema, we can create confusion. Or if up is good and down is bad, that's another match problem. But there are cultures that they write right to left, while we write left to right. And then time and evolution sometimes in our minds are represented in different directions. Then that, at least when we're representing them in 2D, that's something that we need to think about. Also, user control and freedom. There are elements where we need to guarantee that the user is in control, and also they can go back and forward and be able to skip things that they already know when they are developing skills. Then that capability of being controlled is really important. Consistency is we use the same type of fonts, we use the same icons to represent the same functions, we don't confuse people using the same icon to different functions, and things like that. Error prevention is how we use the actual interface to avoid the user-made errors. Then how to avoid put characters where we are expecting numbers, or how to avoid putting a non-available data in data fields. Also, we want to support memory using recognition instead of recall. Then you don't want to ask for identifiers in a different screen where you presented that identifier, because what's going to end is the user is going to have to write down that identifier to be able to recall that later. But if you have a way of recognizing, pulling it back, is going to be much more easy in our memory system. We also want to be flexible and efficient, and you have used this a lot as some usability uh, measure. And this is shortcuts, and this is how we allow expert users to go faster through the system. We want aesthetics and minimalism design. Not always more colors or more decoration is better. Actually, the principle is, hey, keep it simple. The KISS principle, no? Error recovery when an error happen, because even though we try to prevent that, sometimes error happens. If you made a mistake, how we can go back, how we can undo, or how we can help the user to solve that error. And help and documentation as itself is how, when the user is lost, they can find their way. Then these are the basic heuristics, and the heuristic analysis works in the way that the experts individually, they go through the interface, they identify these problems, they list these problems, then they combine the problems that they identify, and then you grade them. There are different methods to grade them. One is usually is a scale from 0 to 4. 0 is not a problem for me. 4 is a catastrophe. One could be just typo or interface problem. 2, there is a low risk. 3 is a big risk, but we are not going to kill anybody. The 4, as I mentioned, is a catastrophe. Somebody is going to die, hurt, or be harmed. Then and then you can have the average of different observers to identify which are the most problematic. Why we want to prioritize them? Because again, as when we were prioritizing functionality, you need to prioritize problems to fix. You are going to run out of time, you are going to run out of money. Then we need a method to be able to prioritize those things. Then if we are thinking in AI, in addition to doing this heuristic evaluation, then we should include transparency. Is the behavior understandable? There is explainability. Where is the data coming from? What is the model that is being used? Control, but the controllability of the system. If the AI is doing a recommendation that the user as a human expert doesn't agree, how it can override the AI and provide a feedback loop into that AI. Feedback, and basically in that transparency and explainability, if the AI doesn't have a certainty, is that properly communicated? If the probability of this being true or the recommendation being the strongest, can we quantify that and just present that? And in error recovery, how we are going to go back if the AI is definitely wrong, no? That's something that we need to expand on. Okay, what are the results that we expect from the phase 2? Then we update a usability report that, remember, we are analyzing the users, we are analyzing the tasks, we are analyzing the goals, we are analyzing the interfaces, and in that interface we can say, hey, these are the heuristic findings, these are the cognitive walkthrough findings, these are the scenario findings, and this was the optimization and the improving the score through the iteration that we have in new prototypes. Then we present the new prototypes with that reduced risk, and then we can improve that documentation that is going to support the regulatory review at the end. Now, when we have a point where we think that the prototypes are good enough, then we can move into phase 3, and basically we can go into production. And the goal of this is to validate the safety, usability, and trust in realistic context. And sometimes we can do lab testing, we can do scenario evaluations, we can do field testing in homes, clinics, or kiosks. And this is an iterative cycle with small samples usually, but we don't need to really have a usability lab to conduct this. And usually when we have between 3 and 7 evaluators, we are good enough to identify problems. Okay. Now, if we want to use traditional statistics to do inference, maybe we need a larger sample size. Since we are focusing in identifying problematic elements, then it's accepted to have this kind of discounted approach. When we are doing this, especially for AI, then we need to evaluate the user trust calibration. We need to understand the comprehension of those AI outputs, the willingness of the user to override or question the AI, or if they're just being responsive without any criticism of the AI outputs, and we want to evaluate those recorded from errors that we identified in the previous phase. There are different data collection methods. Again, the observation, that's when we have a lab, you put the people to do things in the scenario, and you can record and take notes and everything. During the observation, you can ask the individuals to think aloud, and then you can take notes, you can record that, and those are going to be valuable data to identify common themes and things like that. We can use the logs and task metrics. Basically, we can count time, we can count screen time, we can count interactions. There are a lot of things that we can count from the screens, the mouse, the keyboard, that allows to understand how the user is actually interacting or going through the app. The ultimate goal would be to have an eye tracking and things like that, but it's not always necessary. Then we can have a satisfaction and trust questionnaires, and some examples are the SUS, the PSSQ, the NASA TLX, and some confidence and trust scale. The SAUS is one of the most recognized tools for evaluation, and I'm going to give you a connection for that, but we can go deeper into that. Basically, it's 10 questions, 5 are graded in one direction, the other 5 in the other direction, to just balance the attention of the user, and it gives us a score that allows us to identify the general usability of a tool, and it has been calibrated over time with some scores. It's not a percentage, it's just an index, and depending of the context, we can use a cutoff that is different for every single scenario. The PSSQ is something that was created by IBM and is the post-study usability questionnaire that is a 17 or 19, depending of the version, questionnaire that allows to identify 3 basic elements. Some elements about the information quality, other ones are about the systems itself, the other ones about the documentation, and an overall aspect of the usability. We have the NASA TLX, that is a way to evaluate the workload and the sources of workload when you are conducting a task. And the confidence and trust scales to have all the questionnaires that are out there. Then, what is the outcome of that phase 3? Then basically we have a validated systems ready for deployment. We have documented usability and the human factors findings. We have some evidence of responsive AI use in the case that we are implemented AI. And then we have a clear traceability that the user input in all these stages in the decisions, and that's going to be valuable not only for the regulation, but also it's a good practice to the outcomes in design. Then when we experience AI, because people are saying, hey, AI is going to change the design because I can prompt a tool and design the interface. Then actually, no. AI is going to help us accelerate the design and development. It compresses the process, and that appearance that we are skipping steps is going to increase because we can accelerate some aspects of the design. But the risk of building wrong things also increases. That's why we still do evaluation. Okay, we don't want to skip just by skipping, but maybe some of the steps are going to be faster because maybe we can have different AI tools to help us to do some evaluations or to conduct some design tasks, but still the user is going to be valuable. And the other thing is what looks like intuition is because when you do this several times, then we end internalizing the experience to the process. Then it's kind of intuitive. You see, hey, there is a problem here, then you correct the problem even before hearing the evaluations. And what AI and the new design process are providing is that the teams can move faster through familiar stages, but we are not really abandoning any of these things. Common issues that teams struggling with the human-centered design is because they are over-focused on the technical innovation. And they are not focused enough in usability and human factors. Then you can have a fantastic tool, but you are not solving any problem. Or the problem was understood by the user in a complete different way. Another thing is if we don't document the decisions, then you are going to be going back and making the same mistakes over and over and over. And those are the common things that we identify in teams. And when we bring AI into the system, then the lack of documentation is going to increase. And that lack of documentation, if we are not careful, is going to increase our regulatory risk, is going to increase our safety concerns, and is going to increase our user mistrust. Then, why the process still matters if we are implementing or using AI? Yes, it's true that AI makes systems faster to build, but also they're harder to understand. And at the end, the behavior is going to be unpredictable. The process exists because we want to reduce that uncertainty. We want to reduce the risk. And we want to prevent overconfidence in the different solutions that we have there. If we want to skip the user understanding, we really need to be sure that the problem is a really well-defined and mature problem that we have been working over and over again. The context is well known and the risks are low. These are conditions that are really, really rare when we have healthcare systems, healthcare information systems, and even worse when we have AI enabled health information systems. Then, at the end, AI can help us, and we can start looking for tools to compress the cycle. We can have rapid iterative development cycles. We can bring AI into the discovery, ideation, and evaluation phases. But it's important to know that the process still exists. Key takeaways: yes, AI is going to accelerate the design, but not reduce the risk. Human-centered design is there to manage that uncertainty. What looks like we are skipping steps is because we are compressing or making things faster. And in healthcare and artificial intelligence systems, human-centered design is more important than ever. A final message is human-centered design is not bureaucracy. We need to understand the human-centered design as a risk management tool for high complexity, high stakes systems like the health information systems. Thank you very much. Here you have some references and see you in the discussions.